So in this video for 10.3, I'm going to do the entire lesson in one video, so it's a little bit shorter. It's a lot of definition based and it's a lot of setting things equal to each other. So I took a lot of this from your textbook directly, especially some of the images, just because I actually think they explain it really well, and I want to be consistent with your notes sheet as well as your textbook. So the first rule we're going to talk about is if we're talking about one circle, so in the same circle, and in this diagram I only have one right now that's in the same circle, if two minor arcs are congruent. So I'm already giving you the fact that AB is the minor arc and it's congruent to another minor arc CD. That's only possible if their chords are congruent as well. So the chords would be connecting either end of the arc. So if I know AB is also congruent to CD, then I can conclude that the arcs are the same. So pretty much what's going to happen for the homework is I'm going to be telling you that different arcs are congruent to each other. Find the segment length. Or I'm going to say different segments are congruent to each other. Find the arc measure or angle, degree. In the second rule, it's saying that if a chord is a perpendicular bisector to another chord, so this would be one of the chords, and this one is the perpendicular bisector, and this is the second chord, then the first chord is the diameter. So again, the first chord is cutting in half and is perpendicular to the second chord, then this first one must be a diameter of the circle. And remember, a diameter runs from one end of the circle to the other, and it has to cross through the center of the circle. Remember, a bisector means it cuts something in half, so it will either have these markings or it will have a numerical value saying this side is 6, therefore the right side is 6, and we'll also be putting in the right angle measure for you. This third rule is basically the opposite of what this second rule was saying. So it's saying if a diameter, so I'm already telling you SQ is the diameter, is perpendicular to the chord TR, then I can conclude that the diameter bisects the chord. So it bisects TR completely in half, and it's also cutting the arc TQR in half. These two work together, and it will be pretty self-explanatory once you get to the math. So if I'm dealing with this example and I want to know what the measure of the arc AD is, that would be using this length here. So in this example, they're telling us these two chords are equal to each other. Therefore, the minor arcs that they connect on either end also have to be equal to each other. So what you would be able to set up is 2x is equal to x plus 40. And I know that again because these chords that attach either end of the minor arc are equal. So then you're going to solve for x. So then we'll be left with, if we subtract x from either side, we'll have x is equal to 40. What's going to be difficult about this homework is I'm not asking you to solve for just x. I want the measure of the arc. So I'm just talking about AD. So I'm going to plug 40 back into this expression. So it'll be 40 plus 40. And your final answer is going to be 80 degrees for arc AD. Very similar in part B, where we are going to be having the two chords are equal to each other. Therefore, the minor arcs are equivalent. And once again, we're finding the measure of arc AD. So we are able to set up that x plus 16 is equal to 5x. And then you're going to solve for x like we did over there. So I'm going to subtract x from either side, and I'm going to have 16 is equal to 4x. And then when we divide by 4, we have x is equal to 4. Now, it doesn't necessarily matter which expression you plug it back into, but I'm just going to say, since I'm talking about AD, only use the expression for AD. And we would find that AD is equal to 4 plus 16 because we're plugging in our value, so it's going to be about 20 degrees. So again, if you remember back to prior examples, we just said a lot of stuff equal. That's what we're doing here. Hold on, let's move this one down because I started to cut some stuff off. In this example, oops, we have to move some stuff way down because I'm just running out of room. In this example here, they are telling us that these chords, again, A, B, and B, C are congruent. Instead of using these notches on the lines, we are giving numerical values. Therefore, because the chords are the same, I am able to conclude that AB, the minor arc, is congruent to BC, the other minor arc, because the chords that attach either end of the minor arc are equal. So number 1, why is that in bold? In number 1, let's make that not in bold and underlined. Let's shrink that a little bit. For number one, if AB is 110 degrees, I am able to say that BC is 110 degrees. And that's all from just looking at the fact that the chords are congruent to each other, that you can conclude that these minor arcs are equal. For number two, if they're telling me AC is 150 degrees, now you have to be careful when it comes to finding AB. What you need to be mindful of is AC has nothing to do with the chord value, so you can't be setting things equal. But what I do know is if this part of the circle is 150 degrees, that there's some amount of degrees left over to go all the way through the rest of the circle. So what I would set up first is 360 minus 150, and we are left with 210 degrees. That 210 degrees is allocated to AB and BC. We know that AB and BC are equal, so if there's 210 degrees for both of them, I would want to cut 210 degrees in half. So you would divide that out by 2, and that means AB would be 105 degrees if we were using example 2 to help us find the degree measure. Again, the reason I know that is I know that this portion of the circle is 150, so the remaining value is spread out between two minor arcs, and if I want to find the value of one minor arc, I have to divide it in half. The last rule, there's not too many questions like this for your homework, but it's still helpful to understand, of course, what to do, is the equidistant chords theorem. So what that's talking about is these little smaller chords that run from the center of the circle. So in this one, it says if we're talking about the same circle, so everything's within one, two chords are congruent. So in this case, we're talking about either A, B, and C, D, or E, F, and F, G, if and only if they are the same distance away from the center. So A, B, and C, D are allowed to say they are congruent if E, F, and E, G are the same distance away from the center of the circle. And in this case, I know that they are because they're both making a right angle with their respective chord. So for here, they're telling us already that the chords are equal to each other. So they're already saying QR and ST are equal from the directions as well as from marking them up as both 16. Therefore, I'm able to conclude, like from up here, that these little smaller areas are equal to each other. So I'm able to say that CU is equal to CV. And then to set up the math for that, we're able to say 2x is equal to 5x minus 9. And then we're going to, wow, I'm messing up my typing. We're going to subtract 5x from either side. So we're going to have negative 3x equals negative 9. And then we find out that x is equal to 3. Now again, be careful because we want the actual length of CU. So that means we'd have to plug x back into our equation and find out that, oops, CU is 2x, so we'd want to be dealing with 2 times 3, which is equal to 6 for our length of CU. Again, read the directions. It's not just telling us to solve for x, it wants a length. Number 3, 4, and 5, it's just a quick review. So at this point, if you want to stop watching, I'm okay with that. It's just reviewing a bunch of different little aspects from the prior rules at the top. Why isn't it letting me type now? Okay, there we go. So for number 3, if I'm looking at this image, I see that it's asking what is the length, or I'm sorry, the measure of arc CD. Well, I see that this diameter is perpendicular to this chord. Therefore, I can conclude that it cuts not only the chord in half, but it's also cutting the arc in half. And that would be using this last rule up at the top. So we are able to conclude then that CD is equal to DE, and we are able to set up an equation to solve. So then I would be setting up 9x is equal to 80 minus x, and then I would be adding x to both sides, so I have 10x is equal to 80, and then I have the value of x is equal to 8. Then from there, I would have to plug 8 back in because I want the value of the arc CD, so I would say 9 times 8 is equal to 72 degrees for CD. Now, if I know the answer for CD, I also know the measure of DE because they are the same length. And if you wanted to plug back in X, you would still get 72 degrees. And for number 5, if I want all of CE, I'm just adding up those two minor arcs together. So it's 72 times 2, or 72 plus 72, and we are going to have 144 degrees. Good luck on your homework tonight. I know this video was long, but it's just a lot of repetitive work, and I wanted you to see all of the examples you could have.